Okay, the following is a video for 10.4 notes. This is part 2 of the notes. And we're talking about angles and polygons of inscribed figures. So by inscribed, I mean inside of the circle. Okay, so the vertices of a polygon are actually on the circle. So the first thing I want you to do, if you weren't in class, is to label this point here as point A, okay, the center of this circle. And then somewhere over here, I want you to label this as point B, okay? And then what I want you to do is take that point and use your straight edge and go all the way across the circle, okay, through the center to the other side to make a diameter, all right? And we're going to call that point over here point C. Okay, and what we learned from our exercise was that if I take any point here, okay, along this semicircle, all right, and I plot a point, I'm just going to put a point right here. I'm going to call that point D. What I'm going to do is I'm going to create a triangle with D, B, and C. So I have one of the lengths of the triangle is the diameter. Okay, now one thing I want you to notice here about this situation is that if I were to find this arc here of the semicircle, the measure of that arc, the measure of this arc is 180 degrees. Okay, it's this angle here, 180 degrees. So then what we know about the inscribed angle is that the inscribed angle is half of that length, which is going to be 90 degrees. So we know that this is a right angle. So what we can say about this is that if triangle DBC is inscribed and if BC is the diameter, then angle D must be a right angle. Must be a right angle. Okay, right? Has to be a right angle, right? Okay. So let's apply this idea. Okay, and this is what we talked about. We did this on Sketchpad. You guys did this in class, but if you weren't in class, this is what we did. And so what I want to do is I want to apply this idea to find the measure of angle J here, and then apply this to find the measure of angle K. All right, so what I want to do is, because I can say that this segment JK, okay, we'll assume that this is the diameter because it goes through the center B. Okay, that's how I know it's a diameter. Then I know that angle H is a right angle. Okay, so if I wanted to find angle J, then I would need to find what X is. Okay, and I know the relationship between those two angles because in a right triangle, if the two non-right angles, I know that those angles add up to 90. So I can say that angle J plus angle K added together end up, oh dear, angle J plus angle K added together give me 90 degrees. Okay, so what I can do is I can then say, okay, 5x minus 2 plus 2x plus 8 is equal to 90. So 5x and 2x combined give me 7x, and then negative 2 plus 8 gives me positive 6 is equal to 90. So I can subtract 6 from both sides, and I end up getting 7x is equal to 84. And so then if I divide everything by 7, I end up getting that x is equal to 12. Okay, so now what I can do is I can take that, I can plug it in for angle J and find what that angle is. And so I would take 5 times x, but x is 12, so I'm going to write 5 times 12 minus 2, which gives me 60 minus 2, which gives me 58 degrees. Okay, then let's find angle K. Angle K is going to be 2x plus 8, so you get 2 times x, x is 12, so plug in 12, plus 8, and I get 24 plus 8, which ends up giving me 32 degrees. Okay, so just knowing what the picture tells me, I have to draw some conclusions about that and know that angle H is a right angle and this is a right triangle. Okay, so we have this other scenario here, and so what I want you guys to do, I think we called this point R here. All right, and then I had this to be Q, some point over here, another point up here as point P, and then say this point here we'll call S, and then this point over here we'll call T. All right, and what we found out about this is that if I create an inscribed polygon, okay, of 4 sides, then we found something unique about some of those side legs, okay? And the one thing, if we draw this picture here like that, remember what we found out? We found out that if a quadrilateral is inscribed a circle, is inscribed, then the opposite angles are congruent, or I'm sorry, are supplementary. Okay, so they add to 180, supplementary. All right, so what I can say here is that angle P plus angle T, if I take those two angles and add them together, I'm going to get a total of 180 degrees, okay? Similarly with Q and S. So if I take angle Q and add that to angle S, I'm going to get 180 degrees, okay? So we figured this out, using Sketchpad, and when you guys were in class, we did that on the notes. But I wanted to show it to you here and put it down actually on the 10.4 notes. So make sure you write that down. And let's look at this last practice problem, okay? It wants us to find the measure of angle S, okay, here in number 9. In number 10, it wants us to find the measure of angle R, okay, which is this one. All right, and now what I know, because this is an inscribed polygon, an inscribed quadrilateral, I know that angle U plus angle S added together give me 180 degrees, okay? I also know that angle R plus angle T added together give me 180 degrees as well. So I can set up some equations, solve for X, plug it back in. I can set up an equation, solve for Y, and plug that back in. So let's go ahead and do that. So if I wanted to solve for X, I would take 3X minus 5 plus 3X plus 5, add those together, and it's going to give me 180 degrees. So then I have 3x and 3x, add those up, and I get 6x. Negative 5 plus 5, those cancel out, and I'm just left with 180 degrees. All right, so if I divide by 6 and divide by 6, I get that x is equal to 30. Okay, and so if x is 30, all right, I need to find angle S. I'm going to plug x in here. So I get 3 times 30 plus 5. And so I end up getting 90 plus 5, so the measure of angle S is going to equal 95 degrees. All right. Now, angle R, same thing. Okay, I can take 11y, add it to 7y, this angle plus this angle, and I'm going to get 180 degrees. All right. Now I can combine these as like terms, and I get 18y is equal to 180, and I can divide by 18 and 18, and I end up getting that y is equal to 10. All right, so now I plug that in over here for r, and I just get 11 times 10, which gives me 110 degrees, and that's what my answer is. So, again, guys, I'm just using the properties that we talked about in class, and using those properties of polygons and angles, of inscribed angles and inscribed polygons to answer questions. So hopefully you've enjoyed this video, and we'll see you soon.